Alright, thank you Prof. Wang for the lovely introduction. So I'm Sia, and today I will present a talk on dialogic reading and children's brain activation that is associated with executive function. So let's start with dialogic reading. It is a specific form of shared reading in which parents interact with children during reading. And to encourage dialogic reading, parents are usually taught the PEER strategy, which stands for prompt, evaluate, expand, and repeat. Prompt means that parents will ask children to talk about the book's content. Evaluate is where parents give feedback such as correction or praises to children. Expand is where parents elaborate on what children have just said. Repeat is where parents ask children to repeat certain words or phrases after them. So, as you can imagine, dialogic reading is linked to children's language outcome. Previous studies have shown that parents tend to use more diverse lexicons during reading. So it comes as no surprise that dialogic reading is positively related to children's expressive vocabulary. Now the question that we ask in our lab is, what about executive function? So now we move on to executive functions. It is a set of cognitive skills that involves the frontal brain region, and it is typically divided into three components that you can see here: working memory, flexible shifting, and inhibitory control. And we focus on executive function because it is linked to children's school readiness. So it is an important aspect of children's development. And we argue that dialogic reading is linked to executive function because children will have to recruit this aspect when they are trying to interact with parents. For instance, if parents ask children about the book's content that happened a few pages ago, then children will have to recruit their working memory. Or if parents ask children to link the book's content with their own experience, then children will have to use flexible shifting to shift between reality and the book. Or if children are doing something that they're not supposed to be doing, and parents stop them, then children will have to use inhibitory control. So the question that we asked in this study is early dialogic reading linked to brain activation that is associated with executive function? And to answer this question, we tested 67 parent-child dyads, 53 of whom took part in the executive function task, and because some of them did not have any brain data, our final sample size was 39 parent-child dyads. It's a longitudinal study, so there are 2 time points. When children were 2 years of age, they participated in this dialogic reading task. They had to read a book with their parents, and the book is Dear Zoo, translated into Mandarin for Taiwanese, the picture you can see here. And when children were about 5 years of age, they had to participate in the DCCS task. So this allows us to measure their executive function, and we measure children's brain activation during this task. So now I will go into detail for each of this. For the dialogic reading task, we video recorded parents reading with their children, and then we transcribed the speech of parents. We coded every sentence for whether parents use any of the PEER strategy. And whenever they use the strategy, we would give them a score of 1. At the end, we would sum up the score and for every parent-child dyad, and a higher DR score would mean that the shared reading session was interactive. And for children's brain activation during executive function, we use the DCCS task, which stands for Dimensional Change Card Swap. This is the experiment setup. So the child would sit on one end of the table, and the experimenter would sit on the other end. It's a card swap task because children have to swap cards. So they would see 2 target cards, you can see here, and they are given 1 test card in every trial. And in this example, they have to sort by shape. So the blue flower will have to go to the red flower. And it's a dimensional change task because after the first block, they have to use another rule to sort the cards. So now they have to sort by color. The blue flower now goes to the blue trunk. And in our study, we have several phases. We started with a practice to make sure that children know what they're supposed to be doing. Then we had a rest phase where children just sit there and do nothing, followed by switch, pre-switch, rest again, and finally post-switch phase. So for our analysis, we focus only on the post-switch phase because that is where children will have to use their executive function. They have to switch between the two rules, they have to inhibit the previous rule, and they have to remember and use the current rule. We also excluded data of children who scored less than 80% because it is likely that they did not use their executive function. So now about how we measure children's brain activation during DCCS. We use fNIRS, so we place probes on a cap and we ask children to wear the cap. There are two types of probes, source and detector. You can see here the ones in red and the ones in green, and the channels are located between the source and the detector. And to measure brain activation, we usually use HBO or HBR, but in our study, we use the difference between these two. And since we are interested in executive function, our probes are located in the frontal region of the brain. So we have 27 channels, and they are located in the left and right dorsolateral prefrontal cortex and inferior frontal gyrus, or DLPFC and IFG for short. As with any brain data, we have to pre-process the raw data before we can analyze them. So briefly, what we did was to inspect data for bad channels, and then we corrected for motion artifacts. We filtered the high and low frequency signal, and then finally we improved the signal quality. And now to the exciting part, which is what we found. So first, we have to make sure that children did activate their brain when they were doing the DCCS task. And we found yes. Out of the 27 channels that we were interested in, those circled in red here are the channels that children activated significantly during the post-switch phase of DCCS. And you can see here that the graphs with the red bar underneath are the channels that were activated significantly during DCCS. So now we can ask the second question, which is also the most important question of the study, which is whether brain activation correlates positively with children's dialogic reading experience. Again, we found yes. Out of the channels that were activated significantly during DCCS, 4 of them correlated positively with children's dialogic reading experience. So you can see here on the x-axis, it shows DR score, and if you remember, a higher score means more interactive shared reading session. And on the y-axis shows children's brain activation, so a larger number means stronger activation. And you can see that on left and right, IFG and DLPFC, children's brain activation correlates positively with their DR score. So, to conclude, I started this talk with the question of whether early dialogic reading is linked to children's brain activation that is associated with executive function. That's this question mark here. And our study showed yes. Children who experience more interactive shared reading also showed stronger brain activation when they had to use their executive function. This implies that interaction during shared reading is very important. It is not just the reading per se. And we see this even at a young age of 2 years. And we argue that this happens because children get to increase their opportunity to engage with their frontal region when they interact with parents during reading. Our study is not without limitations, so notably we recruited families who are mostly from high SES group, so we do not know to what extent our results will be replicated in those from the low SES group. Also, because of data loss, our final sample size was relatively small. Thank you very much for listening.